Yes, hello everyone. In the previous class, we have seen some of the concepts related to the design patterns. So, those are how design patterns solve design problems, finding appropriate objects, and what is the meaning of granularity, specifying object interface. A type in a name used to denote a particular interface. We speak of an object as having the window type. In this, we will see in the coming slides what is that window type and what is the meaning of uh, runtime polymorphism and dynamic binding and all. And here, specifying object implementation. So today our topic is specifying object implementation. Implementation, when it comes to the mind implementation, we need to code something. We need to write a code, and our code should do a specific task what we need. So here, since our topic is, since our main aim of our application is, it should do the desired task, and by making use of certain patterns which are already available. So here currently we are not discussing any pattern actually, but we can make use of certain objects also by making use of a behavior of an object. We know some inheritance concepts and all, and by knowing the inheritance concepts, we can able to build some applications, and we can able to get to know the behavior of how method or how we can make two objects interact with each other. So here an object implementation can be defined by a class also. A class specifies the object's internal data. So if you define a class, if you see a class and you know what a class consists of, it consists of a private data, it consists of a global data, it consists of certain methods also. Methods data, a class contains a class which is represented with a class. Why all this? Why all? A class contains all this because operations perform the task what we want, and the data, that is the variables, are used in certain operations. In the operations whatever we are going to implement, objects are created by instantiating a class. So whenever we are using a term object, whenever you are using a term class, objects are must. Objects are the main building block of a object oriented programming, we already know. And what is the main intention of creating an object is, the main intention of creating an object is to allocate the memory. Allocate the memory how? Next, how to allocate a memory, and how our operations get executed. See, the compiler calculates the amount of memory required. When it calculates the number of variables present, and depending on the data type, it calculates the amount of memory required. When the compiler does this task, then only our program gets executed in the area where the memory is allocated for the program. Next, this is all about the class and the instantiating the class, that is an object. We have to create an object, and then we have to make that class execute, and our operation gets performed. So here is something what we have: a dashed arrowhead line indicates a class that instantiates objects of another class. The arrow points to the class of the instantiated object. So suppose if at all this is the parent class, so this is one object created. So the this is called as instantiator, means a parent we can say, and instancy is called as an object also. But in this term, we have the even have the concept of a parent class and a child class or a subclass also. And this is just a notation which is given for us. What is the meaning of an instantiator, and what is the meaning of an instancy, and how it is denoted? A direct dashed line indicates that we are making use of the service of an instantiator. That is only to be remembered in this diagram, nothing else. And this is, as you already know, this is the class. It has certain operations, it has certain variables, nothing else to be remembered over here. And here we have something which you know. We have a parent class. Parent class also has certain operations, and subclass also will be there, wherein this is an inheritance concept. And parent class, if some of the operations wants to be implemented in the subclasses or in the sub or in the child class, it can be implemented over subclasses also. New classes can be defined. See why this parent class and a subclass concept came into existence, because whenever the programmer feels that all operations are carried out, if all the operations are carried out in a single class, it becomes so difficult for the programmer to identify in one particular class how many operations. If there are certain applications wherein thousands of operations needs to be implemented, at that time if you make a category among those subclasses, I can say, if you make a category by of creating a similar uh, name and creating some names and put those related operations into one category, for that we are calling a one class. So for this we are making use of a concept of a subclass. Subclasses are made just for the convenience of a programmer, and it can be even performed by using a simple one single class also. If it is too small, no need to create a subclass also. And one more thing, we have one special class called as an abstract class. That is one wherein the main purpose is to define a common interface for its subclasses. There is a class called as a abstract class. Even in the object oriented concepts also you have studied this, what is an abstract class. Abstract classes not always it will not be instantiated. An object of that abstract class cannot be created. So that statement which is already you have seen in the fourth semester, even you can see here, an abstract class cannot be instantiated. Instantiated means object of that particular class cannot be done. Like suppose object obj you write, that obj dot operation name, that can't be. Then how to access that? Suppose behind abstract, if you write abstract class uh, uh, name of the class name, if you give, then whatever the operations are written in that, you can make use of those operations in your child class without creating an object. So that is all about in the programming I told. And in the object, in this software architecture, and that too in the design patterns, the operations that are abstract class declares but does not implement are called abstract operations. See, we can just declare in the parent class as an abstract. The implementations can even be done in the subclasses or wherever we want, or that can be even done in the parent class also, and we can able to access it. We can refine it, we can redefine it wherever we want according to the convenience. We can able to do the implementation part. More specifically, class may override an operation um, defined by its parent class. Overriding gives subclasses a chance to handle requests instead of their parent class. What is the meaning of an overriding? Overriding, if you see the concept of the overriding in the object oriented programming, overriding means the method name remains same. There will be a change in the list of parameters. One method, suppose if it is an add method, it may not have any parameter to be passed. In the same class, one more method with the same name, it may have one parameter. The same name method, it may have two parameters. So by making use of that, you can increase the reliability of that particular class. Subclasses will be the will be used for handling many requests to that parent classes. The same operations are used again and again, and in the multiple contexts. That is one advantage of using the overriding. The name the names of an abstract class appear in slanted type to distinguish them from concrete classes. What is this concrete classes and what is this abstract classes means? Always abstract classes are in a slanted one. Concrete normal classes are the normal approach, normal type or normal font what we use. In this manner itself we will be writing or we will be denoting. And the slant type is also used to denote abstract operations. So if you see, this is an abstract class. Its operation is nothing but it's a method name. Here it is written as a operation. What is delegation? See, delegation is one more concept wherein you take many classes into consideration, and one one window or one class assigns the responsibility to carry out to the other class. That is called as a delegation. Before going to the explanation of this slide, let me first clarify the word delegation. Delegation means assigning the one's responsibilities to others. Assigning the one's responsibility to others. For that we call it as a delegation. Delegation is a way of making composition as powerful for we use as inheritance. Inheritance is a powerful concept, and why that inheritance concept is taken here? Because in an inheritance we have many uh, classes. One class makes use of the operations of other classes. So there the delegation concept comes into existence. And in delegation, two objects are involved in handling a request. A receiving object delegates operations from its delegate. See, receiving object. See, suppose if my class is a subclass, I'm receiving some instructions from the parent class. So I'm delegate, and the person who is giving, that is a parent class who is giving some responsibility. So that is a delegate class. Okay. So let us see that in this context or in this diagram, how one is assigning the responsibility to the other. Okay. Here, what all classes we see? The figure seems to be quite big here, but it is very simple. If you understand it, it is very simple. There is a class named window. There is a class named rectangle. One method name is there in this window class, that is area, and there is one method name present in the rectangle, that is area. Both classes have the same method name, that is area. And here two data types are used, that is width and height. Let's not worry about what is present here and all. We need to only bother about what is the relationship between window and the rectangle. See, window type is one class and a rectangle is just a shape. So it means that rectangle class, when it operates, it should draw only the rectangle itself. Okay, it should draw the shape rectangle itself, nothing else. The work of this class is totally defined here. By taking this two data, that is height and width, it has to draw. And how much area it can draw, it is based upon the width into height by making use of that data. And if you see the example explanation, instead of making the class window as a subclass of rectangle, the window class might reuse the behavior of rectangle by keeping a rectangle class variable and delegating specific rectangle specific behavior to it. See, specific behavior is delegated to this rectangle. what is that specific behavior is delegated to this rectangle is